Hello and welcome back to Every Problem. This is Stewart Calculus, 8th edition. Section 1.4, problem number 4. Problem number 4 has an A and a B part. And also, before we get started, I'll just say it's pretty algebra intensive. So we'll have to work through everything nice and carefully. So let's go ahead and get started. For part A, they have x to the 2n times x to the 3n minus 1 all over x to the n plus 2. Okay, so the directions for this are use the law of exponents to rewrite and simplify the expression. So let's just start with what comes to mind first, and for me, that's going to be this top part here, the numerator of our expression. So here we have x to the 2n times x to the 3n minus 1. So we know with the exponential, the laws of exponents, that if you have the same bases and you are multiplying, then you can add the exponents. Okay? So we're going to do that. We're going to have x to the 2n plus 3n minus 1. And that's all over x to the n plus 2. Okay, so this will simplify to, let's see, 2n plus 3n is going to be 5n. And minus 1 is going to stay minus 1. So that gives us x to the 5n minus 1. And that's all over x to the n plus 2. Now, when we are dividing, as we are here, anytime you're dividing exponents with the same base, in this case we have base x, then you can subtract the exponents. And so with this, you'll see we have to be pretty careful when we are subtracting, because here's why. We have 5n, we have x to the 5n minus 1 minus n plus 2. So notice this minus, you have to distribute the minus sign. So that gives us x to the 5n minus 1 minus n minus 2. So here we've got 5n and n and minus n, so that's going to go to 4n, x to the 4n, and then we have a negative 1 minus 2, so that's going to give us minus 3. And that's our answer for part A, is x to the 4n minus 3. Okay, so part B, again, it's going to be a little bit algebra intensive, and I'll go through why I'm doing the steps that I'm doing, so if you want, you could maybe speed the video up or skip some of the steps if you're just looking for the quick answer. So anyways, for part B, it has square root of A times another square root of B. And what we see is A is just under a normal square root, and B is sort of in a double square root. Now, there's a way that we could rewrite this. We could rewrite this as A root B all to the 1/2 power. And if I flip back, I've got the book in front of me. I'm not sure if you have the 8th edition book in front of you as well, but if you're on page 47, law of exponents number 4 says ab to the x equals a to the x times b to the x. So that means we'll be able to split this up. And now I know there's more to problem part B, so maybe I'll write the rest of it out really quick. So part B, the full problem is all of that divided by the cubed root of AB. Okay. But anyways, this top part here is what we're focusing on at the moment. And so that's equivalent to a root b all to the 1/2 power, which is also the same as saying a to the 1/2 times root b to the 1/2. Well, the square root of b is also the same thing as saying b to the 1/2. So we could have b to the 1/2 times, not times, but to the 1/2 power. Now, using our law of exponents, when you have a power to a power, you can multiply those. So this expression gives us a to the 1/2 times b to the 1/4. Okay? Great. Now, I understand this is a lot of steps, but I'll show why we're doing all of this. So now let's go ahead and drag the denominator down here as well. And again, here we see the cubed root of a times b. So I'd like to split that up as well. So we have our whole fraction, a to the 1/2, b to the 1/4, all over. This is going to be a to the 1/3 times b to the 1/3. Now, the next thing I'm going to do is I'm going to split up our fraction. That way we have two fractions that we're multiplying together. So I'm going to have a's with a's and b's with b's. We have a to the 1/2 over a to the 1/3 times b to the 1/4 over b to the 1/3. Okay? Now from there, we know that when we have the same base but different exponents and we're dividing, well, we subtract. So now we have a to the 1/2 minus 1/3 times b to the 1/4 minus 1/3. Okay? Well, in order to subtract these fractions, we need a common denominator, right? So let's go ahead and get a common denominator. Now we have a to the 3/6 minus 2/3. So that's our a term, times b to the, well, let's see, with the denominator 4 and 3, our common denominator is going to be 12. So we'll have b to the 3/12 minus 4/12. Okay? Good. Now, I made a little error here. Let me catch that really quick. That wasn't supposed to be 2/3. That was supposed to be 2/6. Okay. Anyways, so now we'll subtract our exponents, and we get a to the 1/6 times b to the negative 1/12. Okay. And let's see. Just making sure I did all my steps right since there's so much algebra involved, right? So that gives us the 6th root of a over the 12th root of b. And yeah, I'll probably leave it at that. I know we could do all sorts of rationalizing the denominator and everything. It depends on how simple they want your final answer, but I would suspect that's probably about where it needs to be. So yeah, we'll just leave it at that, and That's going to be the solution for part B.